right, so to address doubling time, the first thing that it says that it takes $7,100 to double when it's invested at an interest rate of 2% compounded continuously. Now, the reason why we're going to start with the PERT model, of course, is because we see this word continuously. So remember, when you see the word continuously, you think about the PERT model. All right, so first thing is, what does the $7,100 represent? That 7,100 represents the principal because it does say that it's being invested. So that's your beginning amount. So we'll plug in the 7,100 for the principal. The other number that we have here is, of course, the interest rate of 2%. Remember, interest rate always needs to be converted into a decimal. So R is not going to be 2%. The R is going to be 0.02. So we'll have 0.02. And then the time variable is what we're trying to find, right? So it says find the time. So the question is, what is the time that it's going to take? Now, you'll notice here I have exhausted all of the numbers possible, right? I've exhausted the principal, I've exhausted the rate. There's no more numbers out there for me to find. So what I have to use now to find my A value is I have to use the fact that I'm trying to double this money. So if I start with the 7,100 and I double it, then that means at the end, I am going to have, again, if I double it, I'm just doing this for emphasis, if I double it, I'm going to take the 7,100 times it by 2, that's going to double it, and that means at the end, I'm going to have 14,200. So they don't give us A, but they do tell us that we're trying to double the money. So that tells us we need to take the principal times it by 2, and that will give us our A end amount. So there's a little bit of critical thinking that has to go on there to get the 14,200 as the A value. So I'm going to write this equation below here. This is what I'm trying to solve. I'm trying to solve 14,200 is equal to 7,100 e to the 0.02t. Now, what I really like to emphasize when I'm looking at this equation is, where is my variable? Remember, E is our Euler's number, the 2.718. That is not a variable. What we're trying to do here is we're trying to find t. So you'll notice that the variable is in the exponent. So because that variable is in the exponent, we have an exponential equation. Now, you can memorize all of this, but I always think about, like, when I have an equation, I am trying to undo PIMDES. So before I worry about that exponent, the first thing I'm going to do is I'm going to say, do I have addition and subtraction that I need to undo? You'll notice on both sides of the equation, there's no addition and subtraction to undo. Then I will say, is there multiplication or division to undo? And I do notice that there is multiplication there. I have 7,100 times. So I will divide both sides by 7,100. Now, of course, when I take 14,200 divided by 7,100, that is going to give me 2, and that should not come as any sort of surprise because we were doubling the money. I will mention, if you were trying to triple the money, when you make that division, you're going to get 3. So that connection between 2 and double is very much there. And then on the right hand side, we have e to the 0.02t. All right, so then what I do is I say, okay, I'm trying to undo PIMDES. I have undone the multiplication and division. Now I simply need to undo the exponent. Now, to undo the exponent, remember that is where, to undo e to a power, we are going to take the natural log of both sides. So we'll take natural log of 2, natural log of this. Now, because we are working with compounded money, and compounded continuously money always has a base of e. Every time on these questions where it's compounded continuously, the natural log has a base e, the exponent has a base e. So we remember that these same bases cancel. Now, yes, you could bring the power down. However, you are just working extra hard there if you bring the power down, because you do have the natural log of e, those bases are going to cancel. So that is simply going to give us natural log and e cross out, and then 0.02 t. And then to solve for t from there, we will simply divide both sides by 0.02, divide by 0.02. So that gives us the natural log of 2 over 0.02 is equal to time. Now, you do have to kind of watch to see like what they want it rounded to. Sometimes they want it rounded to the nearest tenth of the year, the nearest year. But one thing I just want to mention in your calculator when you put this in, remember that you need to hit the natural log of 2, so the natural log button, 2, and then be very careful to close your parentheses to end that natural log and then divide it by the 0.02. And that is going to give you approximately 34.657. And again, that would be the time in years that it would take to double your money.